Okay, so welcome to One-a-Day Unit 1. Today I have this questions and for the last 7 years it only appeared about 4 times, and it's essentially is the topic is body submerged in a fluid, but it's actually Archimedes principle. So let's have a look at this one. Very small percentage across the United Kingdom actually completed these questions with full marks. Okay, there's two reasons for this. Number one, there's no formulas on the formula sheets, but you do have to use the formula. The other thing is people often misinterpreted the word weight. So the first question um, it's a part A questions, and it's really nice here. It's worth 8 marks, but it's divided into two sections, which basically giving you a hint as to what you have to work out first to solve the part B question. So for 9 marks, it's most likely it will just give you one questions to try and solve and not breaking it down for you. So um, in this problem, we have an object, and an object is floating on a fluid. Now, the word we're looking for is what we call submerge, or in other words, is buoyancy. So the calculate the weight of the block. Now, there is only one weight here, or one force that is leading to the weight of this. Just like human, if you're sitting on a chair, is only one force, and it's caused by gravity. And so therefore, when we talk about weight in physics, we meant weight in newtons as a result due to the gravity. So in this case, for 3 marks, it's straightforward. It's just F equal to mg. So if I put my finger on top of the block and push it down, then you might have a mass times accelerations as well. So there's two things, but there's no forces externally applied to it other than the natural gravitational field pull. So that's just mg. Okay. So the first thing you need to find out is, obviously, you know G is 9.81. We need to find out the mass first. So your mass, which is what people often refer to as their weight, but in physics we say mass. Your mass won't change. If you leave this planet and go to another planet, it stays the same, but your weight will be different. So in this case, for Earth, this m is still your the mass of this. So how do we find the mass? We're not given the mass, but in GCSE you should have learned mouse don't drink Vimto. Okay, so that is your formula. Mouse don't drink Vimto. But we use density symbol in physics using the rho letter, which is the Greek letter. So to find mass, you simply times the density of your object multiplied by the volume of your object. And both of this, the block and the density of the block, are given to you. So the first thing I'm going to check is that are we given the SI unit, and therefore we're given meter cube and we're given kilogram per meter cube, and both are already in SI units. So therefore we can multiply rho by volume to get the mass. So if I write it here, so rho is 800 multiplied by the volume is 33 times 10 to the power minus 6, and that's your mass times by the gravitational pull, and so therefore is 9.81. And so if you put that in the calculator, you will get your answers. So I'll do that now. Okay, so it is 0.2589 dot dot dot, and we will need to round this to, you got, because you start with a 0 point at A level, if it's less than 1, you round to 3 significant figure. If it's 1 point something, you round to 2 decimal places. So in this case, it's 0 point, so I need to round to 3 significant figures. So I will round this to 0.259. And the force is in Newton. The unit is Newton. Okay, there you go. So that's the easy mark there, but a lot of people got this wrong because they, number one, they forgot the formula for um, calculating density, mass, and volume. Okay, for the next part, calculate using Archimedes' principles the height h of the block that is below the water level. Okay, so basically, when you put a item on a fluid, it will either sink, it might submerge, but it might submerge fully or it might submerge partially. Now, according to Archimedes' principle, so it states that um, uh, the, the body submerged in a fluid is going to incur a up thrust onto the fluid, and so therefore um, when equal to the weight of your of the body. So let me just show you here. So therefore, there's going to be in the past there's going to be up one mark just to explain what is Archimedes' principle, but there's no questions or anything else. So it states that there's going to be an upward buoyancy force exerted or induced by the body immersed in a fluid, and is equal to the weight of the fluid that the body displaces. So in other words, what we're trying to say here is that if you have a beaker of fluid, when you submerge an item, let's say a block, into the fluid, that fluid is going to displace by a certain amount, which is the h. And this displacement, this volume that it displaces, equals to the weight of your body that you submerge it in. So that means that if you can work out the volume of this displacement, you can also work out the weight of or the density of this mass. So back in Archimedes' time, a king wants to have his crown made. So therefore, he used this technique without damaging the crown to work out the material. So therefore, it can make a better quality, like gold, for example. Or you can check if the item is really made by the material one said it's going to be made of. Okay, because then that way you can work out the density. So that's the story behind this. So now what we do, because it doesn't come with a formula, but it does tell you something though. Every exam, if this questions comes up, it will tell you to use Archimedes' principle. And this principle essentially is, it says the force exerted by the body. So therefore, converting this principle, that meaning is the force equal to the product of the density and then also the area of the body, the cross-section area of the body, and then the times by the, let me rephrase that. Okay. Times is due to the G force, so G, and then times by the volume. Okay, that is the formula to solve this problem, and that's based on the Archimedes principle. So, but remember though, this is not the Archimedes principle. Okay, this is just a formula. The Archimedes principle is the sentences I've just shown you there. Okay, so to find H, this is where people get stuck. Where is the H in this formula? Okay, well, before I do that, I want to give you a hint. Is that if there's a formula actually in the formula sheet that looks very similar to this, and you've guessed it, that's the hydrostatic thrust, the force of hydrostatic thrust. And it's AX, isn't it? Well, A is the area, meter square, and X is the centroid position of the fluid. And that's in meters. What is meters squared times meters? And that gives you meter cube. So basically, that hydrostatic thrust should give you a hint. That is actually the V. So if you can remember rho GAX rather than the formula in the formula sheet, which is I think is rho AGX. If you put A and X together, it might help you remember that it's actually the volume. Okay, so well, in this case, guess what? The V is A times H, because that is how much the body is being displaced or submerged into the water. Okay, and that would equate to how much water get displaced as well. Okay, so we have this formula then. So I get rid of T because it's not a hydrostatic thrust. So we just work out force, and that is 0.259. Now, this is the next argument. What density are we applying to? Well, you are putting a body into a fluid. And what is it that you're affecting? You're affecting the fluid. So therefore, it's always the role of the fluid. Now, if you think about this, if you swim in the sea around the British Isles, and then you go and swim in the Dead Sea, you will find your buoyancy are different. But you haven't changed. What's changed is the fluid. It's the density of the fluid. So that is it must be the one that is affecting, because it requires a different force to displace the fluid. As a result, you are using the same force because it's your own body. The force of due to the fluid is affecting your buoyancy. So in the Dead Sea, it's very, very difficult. In fact, it's impossible for a human to dive and touch the bottom of the seabed, because your body can't fight. You don't have the strength to counter the force. So we are dealing with fresh water here. So it's just simply 1,000 multiplied by 9.81. Okay, remember, due to the fluid, yeah? And then times by your area, which you can work, I think it's given to you at the top, is 0.02. And then finally, you got times by H. Now, I've got some students got stuck with this, which I think is really weird. So if you don't have a confidence in maths, you could have just multiplied those three numbers to make a coefficient of H. Then you will see that you just have to divide by the coefficient, right? But when you write it like that, some of my students get stuck and don't know what to do to rearrange the formula. Well, all of this are multiplying by h, so therefore to get rid of those numbers, you just divide by those numbers. Yeah, no, 9.81 and times 0.02, because you divide by both sides, right? And so therefore that get rid of, so that will cancel out on this side because you're also dividing by the same, isn't it? So many people can't see it, which is quite interesting in the teaching point of view, that there are some misconceptions bringing from the key stage 4 time. So we got, so if you put the count on in the calculator, this calculations, then you will work out the force, sorry, the h, the displacements, or the amount of the height of the material that is submerged into the fluid. Okay, so that is going to give me okay, so I got 0.00132 dot 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 meters. Okay, so that means is about 1.32 millimeter. Now I think let me just double check the if I have if 0.02, yeah, that's it. 0.02 is indeed the area in meters square, so there's no SI unit. It just I feel it's a little bit small. Um, it only it only go in by 1 millimeter, but it may be that's the case. So what we'll do, just before we stop the video, um, 1.32 millimeter and 0.2589. So I'm just going to close this because it's slowing down my computers. In fact, yeah, let's just go with that. I'm just going to stop the video now. Okay. So just remind everybody, that's the principle. So Archimedes' principle states that the upward buoyancy force exerted on the body immersed in the fluid is equal to the weight of the fluid that the body displaces. Okay, it's quite a lot of wordy things, but that's the most accurate way to explain um, the Archimedes principle, because that is what it is.